Hey guys, by now you've watched the video for how to set up your transformations foldable. So what I want you to do is pause the screen and kind of copy what you see. So listen real quick before you do that. The colored writing is going to be on the tabs that are folded in. So when you look at it and you fold open the tabs, you're going to put each one of these different colors down, one on each tab. So the first tab will say vertical shift up, the next tab will say horizontal shift left, and so on and so forth. Please make sure you copy everything. Obviously, the graphs and the little equations, those are going to be on the graph section of the foldable, okay? So take about a minute, pause the screen, and press play when you're ready. Okay, so at this point, you have already copied down everything on the screen. If you haven't, you do need to pause and do that first. We're going to go ahead and zoom into each one of these and have a conversation about what you need to do when you see this kind of transformation, okay? All right, so the first thing I want to talk about is vertical shifts up and down. So whenever you have something, we call it transformation D. Whenever you have something that is adding or subtracting after your function, so for instance, let's say you had f of x is the absolute value of x plus 3. What that's going to do is take our graph, and instead of starting at the origin, it's going to shift it up 3. Our new graph would look like this. It's the same shape, it's facing the same direction. The only difference is it's 3 boxes or 3 units higher, okay? In comparison, let's say we did almost the exact same equation, but now we have a minus. So I'm going to make my new function, f of x equals the absolute value of x minus 3. Well, in this one, same shape, same direction, but now I'm going to move my graph 3 boxes lower. Facing the same direction again. It's identical, it just moved down 3 boxes. Okay, I'm going to zoom out. If you need a chance to write those two down, go ahead and do that. Otherwise, we're going to move on to the blue. Okay, all right, so for the next one, with blue, we're going to talk about horizontal shifts. That means to the left and to the right. So if I start with my first one, if you were taking a problem, let's go f of x is the absolute value of x plus 2. Even though there is a plus there, that actually is going to make our graph move 2 places to the left. So instead of starting at the origin, we're going to move that dot 2 places to the left, and then the pattern is the exact same thing. The way I explain it to my Algebra 1 students is I say if you were trapped in those absolute value signs with your x, they would lie to you. Yeah, they would. So I like to remember that anything that's trapped in the parentheses or the absolute value signs is basically a liar, okay? All right, so in the contrary, if adding moves us to the left and they're liars, what do you think putting something like a minus 2 would do? So let's say our function is f of x is the absolute value of x minus 2. Well, hopefully you know that instead of moving left, that minus is lying. We're going to move to the right. So my vertex moves 2 spaces to the right, but the pattern stays exactly the same. Okay? And again, I'm only copying what fits on the graph. If my graph was bigger, I could make a bigger absolute value. But I don't need to. I only draw what fits on the graph. Okay? If you need to pause that for a second and copy something you missed, go ahead and do that. Otherwise, we're moving on to reflections. Okay? All right, so when we talk about a negative on the outside, okay, so a negative on the outside of your function, remember that that's going to look something like this. F of x equals the negative of the absolute value of x. Basically, we're saying the x pieces don't change, but all of my y's are going to change. So this point is going to come down here. This point is going to come down here. This point is going to come down here. I'm taking all of those points from my absolute value and I'm flipping them. He is going to go upside down. Let me actually move this somewhere where it won't be in the way. Let's put him up here. There we go. All right, so my graph flipped. It is now upside down. Negative out front flips you upside down. In contrary, if I put that negative on the inside, now my x's are changing, okay? So if I say this point went over here, this point went over here, it's a little bit more difficult or a little bit more challenging to see that, okay? I'm going to let you just understand that these are the exact same graph. This one, if I reflect it over the y-axis, nothing changes, okay? So I'm going to make an extra problem on here, okay? So leave that one alone. I'm going to work in a different color real quick. So let's work in brown. Let's say I had my square root function instead. Let's say I was working with this graph, okay? His equation, f of x equals the square root of x. That's one of the ones you learned on Monday. If I reflected him over the y-axis, now I would have this guy. If it makes it easier for you to have at least one example where you can see that whole reflection, go ahead and copy that one down too when I zoom out, okay? If you're okay with understanding the absolute value one by itself, that's totally fine. But if you would like to see an extra problem where it actually changes, then you can copy down the square root one too, okay? All right, I'm gonna go ahead and zoom out. If you've missed anything so far, you could pause it and write your examples. We have one more topic to talk about. All right, so for our last ones, a vertical stretch or a vertical compression happens whenever there is something before your grouping symbols. So something before the parentheses, something before the absolute value symbols. Something is going to take all of my y values and either stretch them up or down or compress them closer to the origin or closer to the x-axis. Okay, so for instance, let's say you have, let's make ours f of x equals 1/2 of the absolute value of x, okay? So if I took this problem, sorry about that, there's an issue. If I take this problem, 1/2 is going to be between 0 and 1. So I'm going to compress each of these points. So for instance, this point is up at 4. I would relocate him to 2. He's half as high. This guy is up at 2. I would drop him halfway to 1. So my graph isn't moving, it's just flattening out. You can kind of think about that like slope. Same idea. If I reflect that on the other side, my 4 comes down to 2. My 2 comes down to 1, and so my graph is just increasing at half the speed. All right? All right, let's go ahead and look at the second one. Okay, so this one, I actually made an error. If you could please switch these two words. I know that I can just kind of switch them around with my choices, but if you would go ahead and maybe scratch them out if you can't fix them. But this top one is actually the compression, and the bottom one is actually the stretch. And that's because anything that happens in the parentheses or in the absolute value signs again, remember he's a liar. So this time, if you have a b that is bigger than 1, it is actually a compression. Okay, it is actually a compression. Okay, so if I have something like f of x with a 2 on the inside, I'm going to compress that instead, and I'm changing the x values, okay? So if my x over here was at a 2, I'm going to move it into this 1. If this guy was at a 4, I'm going to move him into a 2. All right? So it gets skinnier, but it is compressing from the horizontal direction. Same thing. If I'm at a 4 here, it's going to move in and only go out 2. If I'm at a 2 on this one, it's going to move in and only go out a 1. So I would be changing to this new purple graph. Okay? All right, I'm going to zoom out real quick. If you missed anything at all on this page, please go ahead and copy it now. This is going to be the tool that you're going to use for your comparison and your contrast on the next discussion board, and you will have an assignment for transformations on Monday. Please let me know if you have any questions.